Okay, so I don't know if you have this expression in Swedish, Finnish. In Norwegian, it would be "rosin I pølseenden," the current at the end of the sausage. The last talk. As you know, Finland is a hotbed of game development, Angry Birds, etc. At least one of the Finnish game development companies is using APL. And that's what Tomas is here to show us about, some stunning eye candy from Finland.
Thanks. Hello to everyone. It's very nice to be the one who has the last guest presentation during this event, and also about the previous presentation, I must say that was some quite cool stuff. It seemed to work and behave and looked very nice visually. Anyway, this is something I've been working on for some years already, and I think I'm the first one doing what is now happening. But first of all, I'm going to get only a few moments back in time to give you some background. Yeah. It happened that quite a few years ago, there was an ice age in the world where I think 1/3 of the land masses were covered with ice, including most of Europe and entire Canada, I think, and a big part of the rest of North America. And I've seen on the net that you could actually walk from Europe to North America if you wanted. Anyway, lots of ice, with the result that the oceans were, I think, some 100 meters or even more lower than they are today. And the ice masses, for example, in Finland, were up to 3 kilometers high or thick, with a huge mass, of course. They pushed down the Earth's surface with more than 100 meters due to the mass. Then, luckily, later on, things changed. I don't know what things changed in space, and the ice melted. And you can see here now we have Scandinavia, Russia, Finland, Sweden, and Norway. And the Norwegian mountains here are actually older. They don't have anything to do with the ice per se. But it very much looks like, you can see kind of, this is not a picture from right after the ice age. It's just another picture. But it could be. And you can see that it's easy to imagine that for here has been a lot of weight, and the water here is actually meltwater from the ice. Well, that's basically, this was a sea at one point in time. And it's also quite flat here at the Finnish southern part and the east coast of Sweden. So it got better, and an archipelago was created with lots of islands. And if I remember correctly, they are on the Finnish, inside the Finnish borders, around 160,000 islands all over the place. It's very dense. And people tend to move out to the places and build houses and so on. What was left after the ice age was solid rock, as you see here. And they are very kind of shiny and polished, and they sit there very steadily. So this is a typical Finnish-Swedish archipelago view. And the area we are going to talk about now is the south coast, this entire area here. There's a product called Stormwind Simulator, which is what I am trying to sell, and it's aimed at consumers as well as authorities mostly, but also, as said, for enthusiast consumers, buyers. It's a package, it's delivered on a 16 gigabyte USB stick, which I didn't bring with me because it's called a bullet stick. And this is the place where I have my most critical data. That's the last backup. It's always travels in my pocket. And if at the airport say that, sorry, you can't have it, give it to us, then I have no way of destroying the data quickly. So I didn't take it. But it's a stick, and it has an individual serial number, which is my dongle as well. That's copy protection. So this is version 1 of something. It's not quite a good system, but so far. And talking about that, you can easily read for your information serial numbers also from USB sticks with a few commands using .NET, the system.management API. And it has a SQL type query language which gives you tables and blah, 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 and you can extract data from those. Stick has files which are easily manageable. One exe file, Dyalog APL, standalone. One middleware 3D engine, the TrueVision 3D made by a French guy. A few DLL files and lots of data and geographical files. We talk about more than almost 20,000 files. The thing that the files contain is basically, this is a part of the data we are translating into a different format, but we are describing the world. And you can see here, it's a navigation line. The black line is a navigation line with buoys. In this case, the square ones are to be left remain on the left side, and the triangles on the right side, and so on. It's a jitter of understanding and moving the boat in the archipelago in this area, and it's quite complex. Now I'm going to show you a clip of, let's see now. Yep. Is there? There is no sound in this clip, unfortunately, so I have the opportunity of commenting if I want to. It will take about 10 minutes, 12 minutes, I think. And to notice, this is a Dyalog APL program running. Yes, the first and only. And a nice thing is that when recording real-time stuff, it actually consumes very much time. Even so, Dyalog APL manages to be fast enough to maintain the frame rate. So the picture you see here is very smooth. Here's a boat that I used to have. It's a model from real world. They call it 6 degrees of freedom when you can. It's all done the right way. This will hurt. The important thing here is the surfing. Actually, it came as a side effect at some point. When going downhills, the speed decreases to, I think, 11 knots. When going uphills, it goes down to 3 knots, which was very, very nice to discover. If there is an accurate mathematical model and correct physics, you get effects that you know exist in the real world. Yeah, there's always the sunset in the end of the story. And a few typos. Yeah. This one is uploaded to YouTube as well, but not really found yet. There are many things that affect what actually happens and how it works on YouTube, which I don't know yet how to control. See now. Yeah, it's not a game, but sorry.
You want to finish and then we'll do the
questions? No, I'm not actually finished, but you can ask now if you want to.
I was going to ask about the radar element. Will that be a configurable module, because radar systems vary considerably?
Yeah, it's. I have been asked the same question: extract the radar from the rest, and I can say yes, but there are so many things that should be done. You know.
The other thing I was going to ask was, can we have a Viking longship option as one of the boats?
Of course. So now we have seen Dyalog creating, enabling us, more or less us, to do all kind of stuff. They have been going into the robot, the Pi, the handheld devices, and so on. And we see more and more getting the good tools to create larger applications that traditionally belong to APL. And the gaming market is big. It's huge, enormous money. In 1 year, gaming revenues $66 billion, growing at a tremendous rate. Because yeah, and retail is slightly down going, but online distribution is going up. A few companies are doing truly well. The leader is Activision Blizzard, who is behind World of Warcraft, 5 billion revenues during 1 year. And the other ones are not far behind. And these are all games that we know the names of. And these are the games that we buy to our kids for Christmas or birthday, and it happens all over the world each day. $180 million a day revenues in the gaming industry. And in my opinion, E10 plus Dyalog APL. Definitely this is a thing that APLers should be looking at, because there is so much go in this area. A little bit about where I got the data. The European Union has created the Inspire directive, which aims at collecting or gathering, enabling the geographical data that has been collected over hundreds of years and making it available to citizens. Yeah, this is from their net pages. Should be collected only once and kept where it can be available. And one important thing is the word transparently available, which Finland, for example, implied, as Finland always implies whatever Brussels comes with. Sweden did not do it right away, and Denmark was quite quick to implement, the directive. Anyway, it means that when I need height data, I can now today go to a web page maintained by the Finnish state, the Lantmäteriverket, and select quadrants. Say I want this data now. I paint those that I want and do a little simple email order. In a while I get an email message with a URL saying where I can download it from, and I get it, for example, as an ASCII XYZ grid. The same with, so this is land. The buildings also are available in a very convenient way. So I actually process 1 million buildings in the simulator. The forest coverage, equally available as GeoTIFF files online, so I can sit there and collect all the data I need for Finland so far. But this is going to change, it's going to spread out. People are interested in geographical applications. We have seen that, we know that, it's fascinating. And now the European Union the member states are opening data to be used, and they want it to be used. This is the whole point with it, and it's happening right now, so you need to, if anyone is interested, go and take care of it, because the first one, of course, is the first. Unfortunately, the navigational data is not free. It's too operative or whatever. The security demands are very high, so it's licensed material. When I then have the data, I start the routines that run my pretty fast desktop computer for 27 hours in a row and results in thousands of data files which are pre-optimized, pre-calculated and so on. And when talking about gaming, it's a fight against time and a fight against everything. You have limited time to paint one frame, and for example, of that reason, we pre-create 3 resolutions already at this point. We don't do anything like that in runtime. And so the Geo 12 holds 12-meter triangles to be viewed at a close distance, and whatever is far away uses data from this folder here, containing basically the same thing, but at a more rough resolution. This is the area, this is an APL text matrix that I have compressed a bit. And the small X's, the symbols here, we can see they are chunks. Each chunk is 2,2 by 2,2 kilometers in size. And so we have for the Finnish, this is the south coast of Finland and the drivable, or the area with content. So there is quite a few of these data files. Each data file is one chunk. And the yellow box in the middle is what follows the camera all the time. So when I drive the boat, I actually have 9 by 9 chunks following me all the time. If I go in that direction, the system reloads, that's APL code of course, everything, at this end and forgets behind me and follows me all the time. So you can, the data is so huge that you cannot of course keep it all in memory all the time. This game coding is always about optimizing and managing as little data as possible, only whatever is needed. And hence I also pre-create for each cell what objects are available. So you consider this is the content of 2 by 2 kilometer chunk. And I think 86 is a light, so there are lights in that chunk. And this may be a beacon of some sort. Okay, this only tells me at that point that do I have to expect even that this file holds data for beacons or not. Already at this stage, it's pre-calculated. Speed optimization, Morten and others here have talked about the dialogue interpreter and how it does its work. And this is good. But I also want to point out that there are more to consider than getting it from the interpreter in an automated manner. And I think that dialogue should also ask me. It would be polite and efficient. I could tell, I know my data best of all. So I could tell the interpreter with a simple, some kind of additional declaration, whatever, that these are singletons, these are integers, and so on, instead of having to let the interpreter determine or not determine. And this relates to the compilation, the compiling thing that we saw earlier. So use global storage. This is a gaming. The data needs to be there right from startup when you start application, and it's persistent, so it's global storage data. The sun position may be set once, but other routines need the sun position, and once in a while the system may recalculate the position, but there must always be one position available. And at what rate I actually recalculate, I think it's with 5 minutes intervals for that part, but other parts may be recalculated at a faster rate, but only, ever only when actually needed to be recalculated. Simple variable formats are fast in dialogue. Pre-calculate everything possible and reuse cache. Also, when I developed the application, at some point I noticed that it takes 110 seconds to start it, which was quite annoying because you start and make a small change and start and make a small change. So I wrote a file, number 5, store reusable data in files. Most of the time went to actually doing the startup things that are same from session to session, startup to startup. So I just put them into an APL file, component file, which is so extremely convenient for us APL users. We just throw the global data that we know are going to be reused into a component file and read that, and I got the startup time down to 7 seconds, which is quite decent for this kind of application. So the golden rule for all coders: never ever do something unnecessary. Go by how the user experiences time and the usage of the product. Tiny APL code, it's truly still fits on a floppy. The source code of the simulator, which I always tell the C coders and so on. So it's only this much commented, of course, excluded from this, but anyway. How does 3D come? What happens actually? You know from Charlie Chaplin that you put pictures in a row after each other and small changes in between, so you get a live picture. When doing games, all games we see use triangles. Here you can see the boat engine. We are in the boat looking back. There's a boat engine, and here is some kind of beacon. These triangles here are the water, actually, as are here, and here further away is land masses. When doing 3D, it's based on moving the vertices, example for water, up and down, or a little bit, based on some algorithm, which is a function of time. When moving the boat, it's based on setting new positions for the boat repeatedly, calculating, of course, you know, the formulas from school anyway, with small increments and so on. And this is how it all happens. Then when the system, it's the task of the graphics card to do the hard work in parallel. It has multiple processors. Textures are applied on the surfaces on each triangle, which may be a part of a bigger thing. And the textures is artwork. This is why all gaming companies need artists, and they need more and more artists to create nice-looking colors, nice-looking things, and very often use pictures, of course, of the things you want to visualize. In APL, I cannot go through this all, so I decided I will make it very simple. There is a lot of code, and but it's a matter of APL and the 3D middleware engine only. So there is not much magic going on, and there are, unfortunately, this engine I'm using now, it's called TrueVision 3D, is discontinued. It was written by a French, very bright guy, but I talked with someone here earlier about the Unity engine, which is one that runs on multiple platforms, computers and various other devices. And they are .NET enabled. So it is possible with Dyalog APL to make games, actually make games, and even on multiple platforms. When the code at startup, it loads all assets or many assets. It initializes the variables and so on. Then it enters into a loop that goes on until the user quits the application. The loop, each cycle repaints the screen in some way. And it's a loop, so it's not like when Windows came first, and I remember from the Charles Petzold book that it said, don't call me, I'll call you. So this is the callback thing we got from having earlier had some kind of looping solutions. In gaming, we're back to looping solutions, and it's pretty straightforward. And during one cycle, we need to do many, many things, and it's a fight against time to do them so fast that we maintain the frame rate, meaning we distribute things on multiple frames. We maintain queues for doing updates that are not required to happen often. Some things we have to do each frame, but other things like the sun position or many other things are not necessarily need to be done each frame. And then, well, this opens so much, so I won't touch it actually any longer, only proving that this can be done. When then exiting, I do, this is my coding style, I do clean exits, meaning the APL workspace has no hanging variables, no annoying small ABCs all over the place. I clean it all out, so it's, when I save it, it's a clean workspace that I can restart over and over and over again. It's a good coding practice. The TrueVision 3D middleware .NET engine calls are like this. There's a camera object apparently trying to get, well, we are trying to get the rotation, the orientation of a camera object. Or at the second row, we are rotating a mesh, say, for example, a boat. We are along the X, the Y, the Z axis. And I recognize this is half of P to right. And getting events when something happens, like a collision, you ask the engine, was there anything, yes or no? In here, poll events. If this is not 0, then we have something that we need to ask more for to get. So nothing is sent to us into APL code automatically. This is a good and simple and straightforward way to do it all. The APL speed is incredible to do this. I tried to count how many rows of APL code actually went through during one cycle, and I think I came to several thousand rows of code. And there's an additional issue is that when you balance the CPU and the GPU, both need to do work, so the CPU has its own CPU memory, and it sends drawing calls to over the 3D engine to the CPU, which batches stuff until you say draw it all. At that point, the CPU is freed to continue doing whatever the APL code needs to do. So there is a quite complex sharing of time, which is needs to be tried out. But even so, the APL is not the bottleneck. It's the pixel fill that is the bottleneck. That is depending on what kind of hardware you have, how good is your 3D graphics card for gaming. Is it an Intel integrated? It won't work at all. You get a half frame a second, but if you invest $400 in the latest NVIDIA or ATI hardware, you get 500 frames a second. So do it. I want to see APL code in the devices, stuff like front ends like Ilse showed us. In my kid's phone, it would be nice to see something that you know is made with APL, not Angry Birds, but something similar. There needs to be code running in the devices. There needs to be server backends managing the online micro invoicing, by RuneScape Membo for $4.95 membership. That's my kid asked me, Daddy, can I have RuneScape membership? It's only $4.95 a month, which I bought several of those. And as you know, they go on, you forget them and they charge your credit card each month without you actually really knowing. It's one of the points there. So that's why Blizzard Entertainment collects 5 billion in sales in 1 year, because they have such a huge user base. But I think this is an area we should also get into. Yeah, I'm finished now, so any questions?
I've got one question. How much does the 3D engine take care of for you as far as particle simulations? I noticed you had like ocean spray and some of that, and that traditionally that's a very computationally intensive thing. But
it takes care of, you define an object, say how many particles there may be simultaneously, and at what speed they are distributed in what direction, and then you just each frame call an update and a paint, and that's it, and it takes care of it. That's the thing for most engines.
Okay, get another one.
I think you said something quite significant just at the end, in terms of looking at the images. You said you wanted to have your kids and lots of people around the world having this application.
No, not
this
mine particularly, but similar.
But I was just wondering if you and any of the other vendors, including the South African thing just before, put any thought into like a little APL glyph that would appear somewhere on the loading screen or anything like that, that's telling the next generation of APLers this was done with an APL engine.
Yes, I have strong feelings about getting the youth in smart ways into APL, and I have no good solution for this, but I know there is a behavior pattern among those that we want to target. The teenagers that sit with a new laptop he got from as Christmas present and thinks I see cool games, I want to do them myself. How do I do it? And at that point he takes a path. So he searches for solutions that will give him something, get him ahead. And if somehow at that point, along that path, there could be APL signs with cool solutions that he finds valuable, then he may take that part and go on. And there are so many ways to do it, and we know you should actually at Dialog also investigate this. Take a look at participate in discussion forums and see at how do they behave and what is the path they are taking when they go there.
How did you come to that idea? Because 3D in APL is the last which would struck my mind.
Yeah,
it's the first. And second, how much time did it take you to get the first beta version, the first really working prototype?
Why APL? When I started, I didn't know if it would work or not. And the hardware was not good enough until a few years back. So actually I tried this 10 years ago and it did not, it was a no-go. But you know, it's the speed of 3D cards. When you talk about billions, there is development on the hardware side. So the 3D cards, it's NVIDIA and ATI, they are competing and improving all time. Then some point I realized that now is the time it is possible with APL to do it. And I tried more and noticed that actually the APL code is the faster part. And the GPU, the visualizing part, is the bottleneck. So it is possible. The second question, yeah, well, I've been working with this for 7 years full time. Yeah. Yeah, so it took time, but it was worth it. Yeah.
Process, I mean, you've been working with more things than getting stuff I mean, I think I remember following this process, and I mean, there was a whole year that went into developing a correct model for waves and how they move, and talking to professors at oceanographic institutes and stuff like that, and then translate that into physics. I mean, it's not getting the code to display on the screen. I mean, there's a whole lot of issues involved in this game that you see here that has been a lot of work really brilliantly done by Tomas.
Yeah, but it was also a learning process for me because I wasn't a 3D coder at all before. So had I known 3D in advance, it would be had been a much faster path. You had something?
Yeah, there must be shipping simulators out there now that are like flight simulators. Do you is your goal to sell this to shipping companies and people like that? And then how would you? Is it difficult or easy to expand this to other parts of the globe? How much work is that? And what's your market? Have you sold it yet? How much does it cost?
You know what?
What are you trying to do with it? Because it seems really cool.
When I stand here and say to everyone that make applications, let your imagination wander, flow. There is no limit, actually. The problem for me at the moment is the hardware, the USB stick. I need to get rid of it. But after that, what do the gamers, the online multiplayer, massively multiplayer online, blah, 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 companies do? They go on, they enlarge, they function. So yes, you can export the Finnish archipelago to the Chinese without having the Chinese to come here and touch our property. You can put a machine gun on the deck, make it, yeah. You can create sailboats and run a parallel competition to the Volvo Ocean Race and take $12 for something and $8 for something. I mean, whatever ideas you may have are as valid as my ideas. So really, just go for it.
The entire ability to sort of modify the ocean severity, really quite impressive. Do you use any live buoy data so that you can go to some guy and say, this is the way this island looks today because NOAA, well, no, it wouldn't be NOAA, but whatever the Finnish equivalent of the NOAA buoy outside of this island is showing 3-foot wave heights, and that's what it's doing right now. And the other question is, are there applications for training guys to go through Suez? Are there applications for training guys to do barges up the Hudson for oil delivery? All those kinds of serious commercial shipping traffic sorts of things. I mean, there's a lot of need to do that kind of training.
Yeah. The first about waves, I was happy enough to meet the professor, looking like the crazy doctor, black beard and shining eyes. But he was an expert, he's the leading expert on wave modeling in Finland. And he had the theoretical solution, but not the real-time solution. And I had the skills to do a real-time implementation of the theoretical model. So we sat home in front of my television, and he sat there in front of my television, and I had the computer screen picture duplicated, and he said, pointed and said, put 5 there, and I put 5 there, and then I tried it, and it was very funny to do that. And the result was good, because it's a real-time simulation where if you see simulations in advertisements and movies and so on, they are made during 1 hour, and then it's only about, could be a 1 minute clip. So they are created at a slow rate. Then about Hudson River, so on, they model it by hand. They model the Hudson River and the buildings and so on by hand. This is the greatest difference is that I download free data and create it with code. So there was nothing at all placed by hand in what we saw in the clip. The houses, of course, were from a library. The trees are textures that I have taken with camera, so on, and modified with Paintbrush Pro and so on. But the main difference is the automation based on data. And of course, if you can get more data, you can do more automation and so on.
Okay. Is that it? That was absolutely stunning. Thank you very much.
Thank you. Thank you.